So welcome to the third session of Continuity Part 3. Here we will be learning about left-hand limit, right-hand limit, and how to check if a function is continuous by evaluating these. You will also be introduced to derivative of a function and the left-hand and right-hand derivative of a function at a point. Now a function f is continuous on the closed interval ab if f is continuous at every point in the closed interval ab. Now examine for continuity fx equal to x plus 5 if x less than or equal to 1, equal to x minus 5 if x greater than 1. So we check for continuity of f at x equal to 1 since f is continuous for x less than 1 and x greater than 1. Now limit is extending to 1 to the left of fx. 1 to the left means x less than 1. So it will be limit is extending to 1 of x plus 5, which is 1 plus 5, 6. And limit is extending to 1 to the right of fx. 1 to the right means fx is x minus 5. So it will be limit is extending to 1 of x minus 5, which is equal to minus 4. So we have limit as extending to 1 to the left of fx is not equal to limit as extending to 1 to the right of fx. So f is not continuous at x equal to 1 because the left hand limit is 6 and the right hand limit is minus 4. Coming to question 2, examine for continuity fx equal to sin x minus cos x where x not equal to 0, equal to minus 1 when x equal to 0. So if I take, here we don't have left hand or right hand limit because it is only defined for x not equal to 0. So if I take limit as extending to 0 of fx, that will be limit as extending to 0 of sin x minus cos x. Substituting, you get sin 0 minus cos 0, which is minus 1. So, and minus 1 is f of 0. So what have we got? Limit is extending to 0 of fx equal to f of 0. So f is continuous at x equal to 0. Question 3. Fx equal to x squared minus 25 by x plus 5 when x not equal to minus 5. Examine the continuity of f. It is actually x not equal to minus 5. So it is x not equal to minus 5. You can ignore this. So your fx will be equal to, when you factorize x squared minus 25, you get x plus 5 into x minus 5. So that would give you, so x plus 5 will get cancelled and this is equal to x minus 5. So fx equal to x minus 5 is continuous for all x belonging to real numbers since it is a polynomial function. Question 4. Examine fx equal to sin 2x by x if x greater than 0, equal to 2 if x less than or equal to 0 for continuity. So this you can try as homework. You can multiply and divide by 2 and use the fact that limit as theta tending to 0, sin theta by theta is 1. So we use this property that limit as theta tending to 0, sin theta by theta equal to 1. This is what we will use to solve this problem. So just try it. Coming to question 5, locate the points of discontinuity of fx equal to x cube minus 3 if x less than or equal to 2 equal to x squared plus 1 if x greater than 2. So if I take limit as extending to 2 to the left of fx, that will be limit as extending to 2 of x cube minus 3 because 2 to the left means x less than or equal to 2. So there fx is x cube minus 3. So substituting I get 8 minus 3 is 5. And if I take limit as extending to 2 to the right of fx, that will be limit as extending to 2. 2 to the right means x greater than 2. So fx is x squared plus 1. And substituting you get 4 plus 1 as 5. And f of 2 will be 8 minus 3, which is 5, because fx is x cubed minus 3 if x less than or equal to 2. So we have left hand limit is 5, right hand limit is 5, and f of 2 is 5. Or limit as extending to 2 to the left of fx equal to limit as extending to 2 to the right of fx equal to f of 2. So f is continuous at 2. So the point of discontinuity is none because it is continuous everywhere. Less than 2 and greater than 2, it is anyway continuous. Now, question 6. Fx equal to 2x if x less than 0 equal to 0 if 0 less than or equal to x less than or equal to 1 equal to 4x if x greater than 1. You have to examine this function for continuity. So we check for continuity at x equal to 0 and 1 because there is a break at 0 and 1. Now limit is extending to 0 to the left of fx. 0 to the left means fx will be 2x. So it will be limit is extending to 0 of 2x, which is 0. And limit is extending to 0 to the right of fx. 0 to the right of fx means fx is 0. So it will be limit is extending to 0 of 0, which is 0. And f of 0 is anyway 0 because f of x is 0 if 0 less than or equal to x less than or equal to 1. So we have limit as extending to 0 to the left of fx equal to limit as extending to 0 to the right of fx equal to f of 0. All are 0, so f is continuous at x equal to 0. Now now we check for continuity at x equal to 1. Limit as extending to 1 to the left of fx will be limit as extending to 1 to the left. 1 to the left means fx is 0. So that is 0. Limit is extending to 1 to the right of fx. 1 to the right of fx means fx is 4x. So it will be limit as extending to 1 of 4x, which is 4. So we have limit as extending to 1 to the left of fx is 0, which is not equal to limit as extending to 1 to the right of fx, which is 4. So f is discontinuous at x equal to 1. Question 7. For what choice of a and b is fx equal to minus 5 if x less than or equal to minus 1, ax plus b if minus 1 less than x less than 3 equal to 7 if x greater than or equal to 3, continuous. So if I take, you are given that f is continuous. F is continuous at x equal to minus 1. Then now limit as extending to minus 1 to the left of fx will be limit as extending to minus 1. Minus 1 to the left means fx is minus 5. So it is minus 5. And when you take limit of a constant, it is minus 5. Limit is extending to minus 1 to the right of fx. Minus 1 to the right means fx is ax minus b. So it will be limit as extending to minus 1 of ax minus b, that is minus a minus b. And since f is continuous at x equal to minus 1, the left hand limit equal to the right hand limit. So I have minus a minus b is minus 5. Now if I take continuity at 3, limit as extending to 3 to the left of fx will be limit as extending to 3 of ax minus b, because x less than 3 means fx is ax minus b. So it will be limit as extending to 3 of ax minus b. Substituting you get 3a minus b. And limit is extending to 3 to the right of fx. 3 to the right means x is greater than 3. So it will be limit as extending to 3 of 7, which is 7. So I have the left hand limit equal to the right hand limit, or I have 3a minus b is 7. And earlier we had minus a minus b is minus 5. So solving both simultaneously you get a as 3 and b as 2. Now if f and g are two functions continuous at x equal to c, then f plus g is continuous at x equal to c, f minus g is continuous at x equal to c, f into g is continuous at x equal to c. And alpha f is continuous at x equal to c, where alpha is a real number. F by g is continuous at x equal to c, provided g of c is not equal to 0. A polynomial function is continuous everywhere, and if f is continuous, then mod f is also continuous. And all the trigonometric functions sin x, cos x, tan x, sec x, cosec x, cot x are all continuous. Sin inverse x, cos inverse x, tan inverse x, cosec inverse x, sec inverse x, cot inverse x. All the inverse trig functions are continuous at every point in their domain. And if f and g are continuous, then f composite g is also continuous. Coming to question 8, is sin 3x squared minus 5 continuous? So 3x squared minus 5 is continuous because it's a polynomial function. Sin x is continuous because it's a trigonometric function. So sin 3x squared minus 5 is continuous because composite of two continuous functions is continuous. Now a function f is said to have a derivative at x equal to c if f is defined in some neighborhood of c and limit as h tending to 0 f of c plus h minus f of c by h exists and is finite. This limit is called the derivative of f at c and it is denoted by f dash c. So basically you just need to remember this. If limit as h tending to 0 f of c plus h minus f of c by h exists, then you say that the function has a derivative at c and that is denoted by f dash c. Now f dash c is limit as h tending to 0 f of c plus h minus f of c by h. And right hand derivative of f at c is defined as limit as h tending to 0 to the right f of c plus h minus f of c by h. This is a right hand derivative of f at c. Left derivative of f at c is denoted by L f dash c and it is defined as limit as h tending to 0 to the left f of c plus h minus f of c by h. Now f is said to be differentiable if and only if f is differentiable at every point in its domain. If f is differentiable at a point, then f is continuous at a point. But the converse need not be true. For example, fx equal to mod x is continuous at x equal to 0 but not differentiable at x equal to 0. We will prove this again. Coming to question 9, examine fx equal to 1 plus x if x less than or equal to 2, equal to 5 minus x if x greater than 2. Examine f for differentiability at x equal to 2. So if I take right hand derivative of f as 2, that will be limit as h tending to 0 to the right, f of 2 plus h minus f of 2 by h. That's by our definition. That will be limit as h tending to 0. Now 2 plus h tends to 0 to the right. So x is greater than 2. So when x is greater than 2, fx will be 5 minus x. So it will be 5 minus bracket 2 plus h minus what is f of 2? F of 2 will be 1 plus x. So that will be 1 plus 2 which is 3 by h. So simplifying, you get it as limit as h tending to 0, 3 minus h minus 3 by h, that is limit as h tending to 0 minus h by h which is minus 1. That is the right hand derivative of f at 2. And the left hand derivative of f at 2 is defined as limit as h tending to 0 to the left f of 2 plus h minus f of 2 by h. That is limit as h tending to 0, h tends to 0 to the left. So it will be less than 2. So fx will be 1 plus x. So f of 2 plus h will be 1 plus 2 plus h. Minus f of 2 we already saw is 3. So by h, so substituting you get limit as h tending to 0, h by h which is 1. So I have the right hand derivative of f at 2 as minus 1, left hand derivative of f at 2 as 1. So f is not differentiable at 2. So you need to practice. Only practice can make you perfect. So keep practicing each step, every problem with me. Thank you.